Finding deadly gas leaks is critical and often difficult. But a small high-tech firm in Chico, California produces technology to make the job easier. Makel Engineering's motto is "Sensing the Future," and based on what they've produced for NASA, they're spot on. For about 10 years, Makel has partnered with NASA through the agency's Small Business Innovation Research and Small Business Technology Transfer programs, also known as SBIR and STTR. Most of their NASA SBIR and STTR awards have focused on leak detection systems for major missions. The work started with an STTR contract from Marshall Space Flight Center for the technology transfer needed to produce miniature chemical sensor systems. Under an SBIR contract from Kennedy Space Center, Makel built sensor technology that can detect hydrogen leaks. These two programs led to the development of a system that flew on board the shuttle. Around the same time, the firm also developed a detection system for NASA's X-33 program. Both technologies were part of the evolution of what Makel now calls its smart hydrogen sensors, an evolution that produced the sensors the company built for NASA's X-43 vehicle under an SBIR contract from Marshall Space Flight Center.
There's different specifications for each vehicle because there's different requirements, they have different missions, and that requires, even though you have a core technology, some retooling.
Currently, NASA is putting an oxygen generation system on board the International Space Station. The system separates oxygen and hydrogen from water. The oxygen will add crew capacity, and the hydrogen is vented to the outside. As part of that system, Makel has developed hydrogen sensor units for leak detection. NASA's unique lightweight Helios aircraft was powered by a fuel cell system that used hydrogen. Makel worked with vehicle integrator AeroVironment and the Dryden Flight Research Center to develop a low-cost, miniaturized hydrogen leak detection system for the vehicle. The new system was based on the core technology created from their previous SBIR and STTR contracts.
We went through a small engineering phase where we took what we had and we stripped it down, made it as light and low power as possible to meet their needs. And that sort of evolved a new product for us.
That product is a commercial sensor now being tested by the auto industry on prototype cars using hydrogen in an internal combustion engine. Makel also received an STTR Phase 3 contract from Glenn Research Center to further the work originally done for Marshall.
The work we've done for Glenn is focused on basically taking the sensors, both for hydrogen and then also for oxygen. And now we're branching into other species, but primarily those two, and making very miniaturized leak detection systems.
They plan to make the systems use low power and be small enough to be placed in any location. Makel hopes to integrate the new systems into exploration vehicles for NASA. Today, as the company continues to sense the future, they're partnering through an SBIR award from Johnson Space Flight Center to develop chemical reformer systems for a generation of self-powered rovers for planetary exploration.